All right, guys, we are finishing our 3-3 notes. So far with section 3.3, we've really kind of started digging into solving. Because leading up to this point, all except for 3.1.3, we've not done anything with solving. We've done a lot with factoring. 3.1.3 was solving by factoring. We factored it, had two or more things multiplied together to equal 0. One of them must be 0. Now, okay. So we did start with the square root method. So we have found a second way to solve. Now, square root method works well if we do not have a middle term. We do not have an x or a variable to the first power. Because if we have a variable to the first power, we can't use the square root method in and of itself. We have to rewrite it as a set of parentheses squared. Because if we have a set of parentheses squared or a variable being squared, we can get it by itself, take the square root of both sides, and solve from there. And as we look at this next one here, 3x squared minus 9 equals 0. Now there's a possibility we can solve it by graphing. I can grab the graphing calculator. The first thing we do is hit y equals, and we can say 3x squared minus 9 and hit graph. And we can see that it does not cross at a nice point. I think someone could have forgotten that for you. So 3x squared minus 9, we can see it does not cross at an integer spot. So there's either it's fractional or irrational. It's one or the other. So the first step in using the square root method, we know we can because there is not a x term, x without a power. And the first step in using the square root method is to get x by itself, this x squared by itself. So we could, but I would do addition or subtraction first. Here, it wouldn't make a big difference. Let's focus up here, Cade. Cade. It works fine here because we'd have to divide everything by 3. So we'd have to divide the 3x squared by 3, the 9 by 3, and 0 by 3. Well, 3, 9, and 0 are all divisible by 3, so it works out fine. But if it was 10 instead of 9, we'd end up getting, so 3x squared minus 10 is equal to 0. Divide by 3 would give us x squared minus 10 thirds is equal to 0. Now we're messing with the 10 thirds, trying to get it by itself. I just picked 10. I picked a number that wasn't divisible by 0. Or not, sorry, not divisible by 3. Because here, if we did it, it would have been x squared negative 3, 0, and it works out nicely. Because if there wasn't a nice kind of other terms there, then doing division first doesn't work as nicely, if that makes sense. Here it instantly worked out nice because 3x squared, negative 9, and 0 are all divisible by 3. Otherwise, let's do addition and subtraction first. And then do multiplication division last, just so we're not having to try to move whatever that term is after division over. But now, since we do have x squared by itself, we can divide both sides by 3. Which tells us that x squared is equal to 3. Is the x squared term by itself? Yeah, the only thing left is the power of 2. And to simplify it, we would take the square root of both sides. Square root of x squared is x. Incidentally, the square root of 3 is just square root of 3. And we do need the plus or minus. Whenever we take the square root of both sides, we have to add the plus or minus. Because we're trying to see what term times itself is 3. Well, the square root of 3 times the square root of 3 is 3. Negative square root of 3 times negative square root of 3 is still just 3. So we have the plus or minus. Now, if we square both sides, put both sides to the power of 2, we don't need the plus or minus. But this is it here. This is also why I didn't cross at a nice point, because the square root of 3 is irrational. So it doesn't give us a nice number. That also means 3x squared minus 9 was not factorable. Well, it is technically factorable, but we couldn't just get there without knowing that we would need the square root of 3. Questions on any of this here? Two fifths times x plus 3 squared equals 5. Now, when we wrote the steps out yesterday, I should have started that with today, but well, our first step was to get the term being squared by itself. Yes? And it might have seemed odd on Tuesday why I said that and not the x squared term by itself, or the variable being squared by itself. And it's because of this here. Because here, the variable is technically being squared, but it's not the only thing being squared. The x plus 3 is being squared. That whole term is being squared. That's why I use term, not just variable. So this is possible, or for this one here, it is possible to use the square root method. And the main reason that we know that is, one, we don't have x outside of that being squared. If it was, say, equal to 5x, we can't use the square root method because we'd have to simplify it and then go from there. Here, the only variables inside that term being squared. So for us, we can use the square root method for this. And our first step is to get the term being squared, which in our case is the term x plus 3 by itself. What's the only thing with our x plus 3 squared? Well, the only thing with it is what? The 2 fifths, yes? So how can I remove the 2 fifths? Not quite, because these two are being multiplied, yes? So to undo multiplication, we would divide. Now, it wouldn't be quite possible to distribute the 2 fifths into x plus 3 because of the square, because our order of operation is parentheses, exponents, then multiplication. So exponents kind of outrules that. But we just want to get that by itself. Because if we divide both sides by 2 fifths, these will cancel out, leaving us with x plus 3 squared equals. On the other side, we have 5 divided by 2 fifths. Divided by 2 fifths is 25 halves. We could have also done it as fraction 5 over 2 fifths, which is still 25 halves. I would leave it as fractional form, because again, once we get that term being squared by itself, we have to take square root of both sides. It's going to be easier to take the square root of a fraction than it is to take the square root of a decimal. Questions on this so far? Is the term being squared by itself? Yes. Is there anything being added to that set of parentheses? Well, no. We have the x plus 3 inside, yes, but the x plus 3 is the term being squared. There's nothing being multiplied, added to it, subtracted from it, or divided by it. So the term being squared, x plus 3 is by itself, yes? So that means we can take square root of both sides. Square root of x plus 3 squared is x plus 3. equals plus or minus. Now we do need to simplify the square root of 25 over 2. It's been a day since y'all had to do these. But what we can do is split it up, because the square root of 25 halves is the same as the square root of 25 over 2. Now the reason we do this is, one, mainly for the calculator's sake, because the 30xs is very nice with radicals. But if we do plug it in as the square root of 25 halves, it gives us a decimal. If we ask it to convert it, it gives us that same decimal back. However, if I go fraction, second square root of 25 over second square root of 2, it does tell us that it is 5 square roots of 2 over 2. It does reduce it for us there. So we have to break it apart. Is x by itself? So again, that last step that seemed odd the other day, solve for x, this is what it meant. Because at this point, x is not by itself. So to get it to be by itself, we would subtract 3 from both sides. Now the funny thing with plus and minus, we're going to still leave it as plus or minus 5 square roots of 2 over 2. And we're going to put the negative 3 in front of it. Whenever we add or subtract something, and we have that plus or minus a number, we're going to put whatever we added or subtracted in front of it. Because what the plus and minus is really telling us is that, for one, that this is saying that we have negative 3 plus 5 square roots of 2 over 2. And we also have that x is equal to negative 3 minus 5 square roots of 2 over 2. We actually have two different statements coming from this. And we normally just, in standard form, we put whatever that number is in front. Since we subtracted 3, we put the negative 3 in front of the plus or minus. If we added, or we needed to add 3 instead of subtract, it'd have been 3 plus or minus 5 square roots of 2 over 2. Questions on how we got to this here? Is negative 3 and our 5 square roots of 2 over 2, are they like terms? Can I add, or take negative 3 plus 5 square root of 2? Can we add those two together? No, the radical makes them not like terms, yes? If they're not like terms, that right there is the final answer. Now, if it had been just, say, 5, they didn't have the square root of 2, well, I can do negative 3 plus 5 halves. I can do negative 3 minus 5 halves. We can combine those. If you can combine them, you need to combine them. Here, because it has the radical, we can't. This is the final answer. Questions on this here? And if you're any doubt, if there is any doubt in your mind if you can combine them or not, we can break them up into the two parts and plug it into the calculator. Because negative 3 plus 5 square roots of 2 over 2, negative 3 plus 5 second square roots of 2, all over 2. Did that give me a number? Well, technically, but no, because I still have the 5 square roots of 2. It just turned it into a single fraction, but it did not give me 1 or a single number. Does that make sense? So it's a way to check it to make sure. Because technically this is a correct answer, negative 6 or 5 square roots of 2 minus 6 over 2 is still the answer, just combined it to a single fraction. Questions on this here? Questions on any of this so far? Again, we do not have a middle term, so we can solve this by the square root method. And the first step in solving by the square root method is get the term being squared by itself. So what's the first thing we can do? So the plus 14, yes? And to get rid of it, we would minus 14, because positive 14 minus 14 is 0, it simplifies it from the left-hand side, telling us that 2/3 x squared is equal to, because 14 or 20 minus 14 is 6. And we would divide by 2/3. Yes. And at this point here, exactly, we can do 6 divided by 2/3, 6 over 2/3 in the calculator, which would indeed give us 9. Questions on how we got x squared equals 9? We feel comfortable with this here? Now, since the term being squared is by itself, we would square root both sides. Square root of x squared is x. Square root of 9 is 3. We are missing one thing. The plus or minus. Questions on any of this here? So, up to this point, square root method works nice if what? We don't have a middle term, or the variable is only inside of a set of parentheses being squared. If it's set up in one of those two ways, it works nice. Works better than graphing or factoring, because some of the ones we couldn't solve by graphing or factoring work with the square root method, yes? So let's do this one here. We don't have a middle term, so this works for square root method. We can subtract 1 from each side, which will tell us that negative 2x squared is equal to negative 7. And what would we do next? We would indeed divide both sides by negative 2 because we need to get the x squared by itself. And we divide both sides by negative 2. We get that x squared is equal to 7/2. And last but not least, we would take square root of both sides. Now the square root of our x squared is going to be x is equal to plus or minus. Now again, to simplify the square root of 7/2, we can do this in a calculator. But if we do this in a calculator, we need to take the square root of the numerator over the square root of the denominator. So square root of 7 over square root of 2, which does simplify to the square root of 14 over 2. At this point, I don't see a whole lot of reason for us to go back through rationalizing these. When we get into our chapter over radicals, we'll go back over that. And that's it. Questions over any of this here? Now, as strange as these numbers seem, if we wanted to check to make sure they work, we can plug them back in. So we said at the beginning, negative 2x squared plus 1 equals negative 6. Square root of 14 over 2. So negative 2 parentheses square root of 14 over 2, close parentheses squared, what was it, plus 1 equaled negative 6, yes? We can plug it back into the original formula. So I was able to show here that the left side does equal negative 6, so both sides are true. We could do the same thing with negative square root of 14 over 2. So negative 2 times negative square root of 14 over 2 squared plus 1 still equals negative 6. It still works. So especially if you're second guessing your answer, you can plug it back in and check it to make sure it does work. It is a way to verify it. Questions on any of this here? I believe we have one more of the square root method before we do a few with factoring. Let's look at this one here. This time we have a set of parentheses being squared, so we do need to get it by itself. So the first thing we can do is, which tells us that x minus 4 squared is equal to negative 5 halves. The set of parentheses being squared is by itself, yes? So the next thing we would need to do is square root both sides. Square root of x minus 4 squared is x minus 4 equals plus or minus. Now when we plug this into the calculator, because I can plug it in one of two ways. We can use the negative on top, or we can put the negative on bottom. I'm just going to do the top way. Second, well, yeah, square root of negative 5 over second square root of 2 is domain error. Okay. Well, I'm going to try the other way. Domain error. Well, we're trying to find the square root of negative 5 over 2, yes? So when we take a square root, what we're really trying to find is what number times itself is negative 5 halves, yes? Well, this is kind of getting a little bit ahead. Let's make it a little bit easier. Let's say negative 4. What times itself is negative 4? So negative 2 or 2, those are our two choices, yes? What's 2 times 2? Well, that's not negative 4, so that doesn't work. What's negative 2 times negative 2? 2. So negative 2 times negative 2 is 4, not negative 4, right? So is it possible to take the square root of negative 4? Okay, so what can we say about the square root of negative 5 halves? Not possible. So here we're going to have to stop. And at this point, say no real solutions. There are no real solutions for this. 2 parentheses x is minus 4 squared plus 5 graph. This is the graph of that function that we're trying to solve. Does it cross the x-axis? No. Now this problem does have solutions. They're just not real solutions. 2, 4, or not 2, 4, 3, 4. We're going to cover it and then come back to these. So at this point here, these kind of problems are just no real solution. There is no real answer to them. And we have not covered non-real numbers yet. Questions on any of this so far? And the non-real numbers are not as challenging as you might think. We're going to do a few more with factoring, and then we're actually done for today. So if we want to solve this problem by factoring, first thing we need to do is get it equal to 0. So we would minus 45 from both sides. On the left-hand side, we would subtract the 45. Now the x squared, 4x, and 45 are not like terms. So we get this here. Is there a greatest common factor? No. So we'll move on to our two sets of parentheses with three spaces. So we would indeed have that. Our signs, since the third term is negative, our signs are opposite. One's positive, one's negative. If the third term is positive, signs are the same and match the sign of the middle term. First term is going to be our x squared term. The third term is really going to be our constant term, the term without a variable. So x squared is our first term, 45 is our third. Now, since we do have x squared as the first term, its only factors are x and x. We can plug those in. 45, on the other hand, has a few. 1 and 45. 3 and 15. 4 doesn't work, but 5 does. 5 and 9. 6 doesn't work, 7 doesn't work, and we're out. Well, 6 doesn't work because 2 and 3 have to work for 6 to work. So we have these here. Which one do we want to try first? 5 and 9. Which one's positive? Which one's negative? 5's positive, 9 is negative. Last thing we can do is check. X times negative 9 would be negative 9x. Positive 5 times positive x is plus 5x, which gives us negative 4x, which is the middle term we wanted, yes? Well, leading into the last step, two things multiplied together to equal 0. One of them must be 0. Either x plus 5 is 0 or x minus 9 is 0. Yes. Because for x plus 5 equals 0, we would subtract 5 from both sides. Minus x is negative 5. For x plus 9, we would add 9 to both sides, telling us x is equal to 9. Yeah, so negative 5 and 9. For the most part, yes, because to solve we have to do opposite operations. Questions on how we solve this here? Questions on any of this so far? Yes. So again, when solving by factoring, the first thing we need to do is get it equal to 0. So we would subtract 2 from both sides. And because 3x squared, 5x, and 2 are not like terms, we just write it back out with our signs. Since there are no like terms, or not like terms, greatest common factors, we can't factor one out. So we go to our two sets of parentheses with 3 spaces. To find the signs, if the third term is negative, our signs are opposite. And then we need to find the factors of the first and third term. One way that will be helpful for finding that is writing the variables in order of decreasing power. So the squared term first, x by to the first is next, and then our constant. So 3x squared, we would have x and x. Now we just need to pick which one has 3. So I'll just put it in the first one. Factors of 2 are 1 and 2. 3x times negative 2 would be negative 6x. 1 times x is plus x, which is negative 5x. Questions on how we got to this point here? Now at this point we can solve, since we have two things multiplied together to equal 0. One of them must be 0. 3x plus 1 equals 0. First thing we can do is subtract 1 from both sides. Minus 3x is negative 1. Then divide both sides by 3, telling us x is negative 1/3. Now we need to solve the other side. We would. Incidentally, if we did graph this, one of these 2 points would have shown up on the graph nicely. It would have been, well, 2, because 2 is one of our nice integers, so it would have shown up on the graph. But negative 1/3 would have shown up between them. It would have still been there, but we would have had to do some other steps to find it. Questions on any of this here? I want to do one more and then give you all a little bit of time to start on the assignment or ask questions if needed. But this one here, number 9 is the last one we're going to look at. Now for these here, really for the one before it and these two, it says find the zeros. Because when we're solving, we're trying to find out what value of x will make the function equal what? 0. So all these values that we're finding are the zeros, or what's values of x that'll make the function be 0. So we call them zeros. We call them solutions. We call them x-intercepts. They're all the same thing. It's just different ways to say it. So for this here, number 9, we're trying to find the zeros. We're trying to find out what value of x will make x squared minus 8x equal 0. That's all we're trying to find. Now there's 2 reasons I call attention to this one. One of them is, do we have a constant term? Do we have a number without x? No, this is the first one that we've come across that doesn't have +4 plus a number after it. But it still works the same way. We can still factor this. So looking at x squared and 8x, is there a greatest common factor? Is there something that's in common with both x squared and 8x? X. So for the first time, x is our greatest common factor. Because that constant term, that number without x, has prevented us from factoring out x every single time. Because if we had +1 added to the end, x is no longer greatest common factor. Because that number without a variable does not have it, but the other two did. Here, this first one we've had where the only 2 terms have x in it. And if we factor it out, we factor an x out of x squared, we get x. If I factor an x out of 8x, we have 8. Well, both terms are factored. X minus 8 is the simplest form, mainly because the power with the variable is 1. That's as simplified as it gets. Now at this point here, we do have 2 things multiplied together to equal 0. So one of them must be 0. We'll leave the one on the left for a minute. We'll tackle the easier one on the right first. So to solve our x minus 8 equals 0, the first thing we would need to do is add 8 to both sides. Because our negative 8 plus 8 would be 0, telling us x is equal to 8. Any questions on how we got the first answer? Okay. Now we need to solve the one on the left, yes? Okay. So we have x equals 0. What is the first thing we need to do to get x by itself? It's already by itself. Realistically, if we do have any polynomial equation, kind of x squared minus x, or anything with a higher power, and there is no constant term, there is no term without the variable, one of the solutions will always be 0. What's also interesting with this, if we graph this one, x squared minus 8x, graph, it crosses the x-axis in 2 places. Second table, again, we're looking for what value of x will make the function equal 0. 8 and 0. This is the one time when x is 0, it does work because the y value is 0. So this one gave us the 2 either by factoring or graphing. Questions on any of these here? And that is it. 4 through 8, 11 through 18, 27, 28, and 31.